Hello, my name is Nguyen, and this is my RoboWrestling Schematic tutorial. So to start off, what is a schematic? It's basically just a diagram of an electronic circuit. So here's some examples. This top left one is something you might see in EC 2040. We have another one on the bottom. It's a combination of maybe EC 2040 and a little bit of EC 2020. But the schematics that we're going to be making look kind of like this. This is the one that I made last year. So before we get into how to make a schematic, we're going to need some more parts. Another part that you're going to need is the voltage regulator. So your battery probably does not match the voltages required by some of your parts. For example, you might have a 12-volt battery, but the TNT 4.1 only needs 5 volts. So we can use the voltage regulator to take that input voltage and have it output that voltage that we want. Most voltage regulators will take a wide range of voltages as an input. For example, it might take in a range of 4 to 40 volts. So when you're picking this part, you want to just make sure that your voltage regulator can accept the battery's voltage as an input, and make sure your voltage regulator output matches the voltage that you need. And another thing to consider is your TNC has a 3.3 volt output pin, so that you do not need a 3.3 volt voltage regulator. It's going to save you some space in your PCB. Another part that you're going to need is a motor driver, and a motor driver pretty much sends signals to power and control the motor. Your coding is going to depend on the model of the motor driver that you have, so you just want to make sure to tell your computer science team member about which motor driver you get so they know how to code. Next up, we have the start module. This is basically just a kind of sensor, and you point a remote at it and it makes the robot start with some certain combinations. We're gonna order these for you, but just be aware of the pin layout. It has 3 pins, as you can see right here, and here's the link to the start module that we're going to be ordering for you. And next, you're probably going to need a battery connector. These are really nice to have. They allow you to plug in and unplug your battery without actually having to desolder it. And you just want to check your battery and see what kind of connector it has and what size it is. XT30 is very popular. It's small. It's you just directly solder it onto your PCB, and you can plug in and unplug your battery as needed. I think I'd recommend this one, but not all batteries use this, so just make sure to check your battery. Some more recommended parts. You don't necessarily need these, but I would definitely recommend them. So first, you want to get a fuse. This is going to protect the expensive components just in case too much current goes through your circuit. Definitely try to get surface mount. There's some specifics on what kind of fuse to get, or the specifications. If you have any questions about that, please just leave a comment, or you can ask me or your mentor. Next up, you might want to get a switch. This is so that you can power your robot without having to remove the battery. You will probably just be okay with SPST, which is single pole, single throw. If you don't know what that means, you can also ask me or leave a comment. Next up, we have screw terminals. This is so that you can remove wires without desoldering them. I would recommend getting the 5mm screw terminals, and you can check the number of pins that you need, or you can get an assorted pack with a variety of number of pins. And the Hive has a lot of screw terminals, so you can definitely go to them to grab a couple. And lastly, we have LEDs. These are good for debugging to see if power is getting to specific parts of your circuit. And you'll probably need additional resistors because if you do not have resistors, they will burn out and not work anymore. Okay, next up we are going to deal with the placement of these parts. So first up, we're going to place the microcontroller. I'm going to assume that you used the TNC 4.1, but if you did not, these steps may still apply to you. So I have the steps listed here. You can read them out, but I'm going to show you how I do this. So first, we're going to go snapeda.com, and we are going to search up the part that we need. It's going to prompt you to make an account, but I already have one right here, so I'm just going to type in TNC 4.1. We're going to look, and we can see this is the model right here, dev 16771. I'll click on this, and it has the symbol right here. We're going to download symbol and footprint. Okay, so it is downloaded right there. We're going to open KiCad. I'm going to make a new project. Actually, make a new. Okay, we're gonna close this one. New project. I like to keep my project in documents, so I'm just gonna name this PCB4. Alright, we can open this. Alright, so the first thing we want to do is we want to get this microcontroller into the library. So we're going to hit Preferences and Manage Symbol Libraries. And from here, we can click this tiny folder on the left bottom, and we can look for our download right here. Okay, never mind. So I already added it, but yeah, you would go in here, look for your model. So mine is actually right here, and you would basically just click this, hit open, and then it would open in your symbol library. And you can hit. I thought I hit cancel. Alright, I'm gonna delete this because it's already here. But hit OK. Okay, and we're gonna open our schematic editor. And to place it, you can either hit this triangle thing right here on the right, or you could press A. I'm just gonna hit A. Be patient. I have a decently high-end computer, but it's still kind of slow, I guess. Search up our part dev 16771. Okay, and we're going to place it. I like to place it top left. That's just me. It doesn't matter where. Cancel. Okay, so that's our microcontroller, and yes, it looks very nice. Alright, next we're going to place our distance and line sensors. So to do this, we are going to use screw terminals so that we do not have to solder or desolder the wires directly to the PCB. If you're using JSUMO sensors, you will probably not have data sheets for some of these. You'll probably need to look at the picture to see what connections need to be made, and yes, we are going to use screw terminals. So, for example, this is the JS, I think this is 40F digital distance sensor. This has 3 wires, as you can see here, one brown, one blue, one black, and there's no data sheet, so we need to go solely based off of the picture. And since this has 3 wires, we would use a 3-pin screw terminal in this case. So to do this, I'll show you again. You could read this on your own time. We are going to press A. Oh, press A. We're going to search up screw terminal. we need 3 pins, so we're going to use this one. Alright, and let's just place it top right. And we have, or my model is going to have 4 screw terminals, so we're just going to copy and paste this 4 times. Okay, so yeah, I've placed them down, and just to make sure we don't mistake these screw terminals for anything else, we are going to name them. So distance. My model had 1 in the front, 1 in the back, 1 on the left, and 1 on the right. So we're going to call this distance front, distance back, distance left, and distance right. Okay, so those are our distance sensors, and my model had 2 line sensors. So we're going to copy and paste this again, but we're going to rename these to line left and line right, because my model had 2 light sensors, both in the front, but it's just left and right. Okay, cool. Next, we're going to place our start module, and we're going to be using the 3 terminal screw terminal to connect this again. It's pretty much the same thing, so let's do that real quick. Put it right here, and start module. Cool. Okay. Next, we have our motor drivers and voltage regulators. The steps for this are going to be the same as the microcontroller. So you could look up Snap EDA, see if they have the symbol. If they don't have the symbol, you could always look on other websites such as Mouser. Mouser also has symbols. If for some reason you cannot still find it, just let me or your mentor know, and we will help you try to either get one built or just request one to be built by someone else. Alright, so I went ahead and placed the motor driver and the voltage regulator off camera, but as you can see, I put my 2 motor drivers down, and I put my 1 5-volt regulator down as well. And I just followed the same steps as I did with the microcontroller, so yeah, just refer to that slide if you forgot how to place. Alright, next up we have power and decoupling. So what does this mean? In the words of Timothy Ignatius Weidman, it's just vibes. Timothy was the electrical lead before me, and when I asked him this question, that's what he told me. So I'll probably give you the same answer just for fun. So why do we do this? It's because capacitors prevent surges of voltage that could potentially ruin our expensive components of the circuit. So in this section, we are going to be dealing with power, so make sure you include your battery, your switch, and your fuse. And just a thing to keep in mind, make sure the positive end of the connector is connected to the positive end of the battery. Alright, let me show you what that looks like. So I went ahead and already placed this again, but I have my 12 volt, which is the positive end of my battery, connected to my switch. You can turn this on and off, and this is connected to my fuse. This will blow if too much current goes through it. And this is connected to pin 2 of this connector. Why? I can't give you a great reason why, but once you convert this over to the PCB, this 2 is the positive terminal for some reason. So yeah. And the negative end of the battery is then connected to a decoupling capacitor, which is then connected to ground. For decoupling capacitors, a very, very common value is 0.1 microfarads. I can't really explain why, but people just use 0.1 very, very often. And this screenshot here was taken from, I think it was Ratatouille, their schematic. So if you want to check that out, it's somewhere on the GitHub. All right, next we are going to be dealing with organization. So we want to make our schematic look nice. So we're going to move the same parts into the same area, add some borders, add titles, pretty much just make it look nice. So let's see what we have here. We're going to start by making a rectangle. This button here on the right, add rectangle. Choose the left corner, and then make an appropriate sized rectangle. And we're going to add a title, TNC 4.1. I selected it from this T on the right here. And for our text size, I think 200 mils is pretty okay. So place that. Next, we have our motor drivers. Let's make a rectangle again. All right, looks good. Motor drivers. Oops. All right, I find it's easier to copy paste just because it saves the need for you to update the text size. So motor drivers. Okay, let's make another rectangle. Let's move these down a little bit. This is our line sensors. Let's move this down a little bit as well. This is our start module. This thing right here at the bottom is our power, or just battery. Either works. And this right here is our voltage regulator. Okay. Let's add the rest of these rectangles. I'm gonna make this big. Okay, so that looks a little nicer. We have this space here in the middle. I'm not sure if I forgot anything, but this is what decent organization looks like. You'll have some space in the middle just in case you need anything else. Yeah. All right, hopefully your schematic looks something, maybe not like this. I'm leaving the rest of this decoupling out so I can show you later, but you're gonna have a microcontroller, line sensors, motor drivers, start module, distance sensors, voltage regulator, and some power thing. All right, for connections, just some general advice. Do not connect your wires across the screen. It's gonna be very messy. Instead, use global labels. These are basically connections that make your schematic look a lot nicer, so you don't have to go cross screen. So I have bro 1 here. It's connected to pin 8, and if I want to connect it to pin 1 on the screw terminal, I just make another bro 1 and I connect it like that. All right, so Here's the microcontroller. There's a lot of pins and there's a lot of numbers and a lot of letters here that could possibly mean nothing to you, but I'm going to explain what some of these mean right now. And if you want to link to this picture, there's a PDF link right here. Let me add something real quick. I really don't want to re-record this again. Okay, to start, we have pins A0 through A17. These are analog input or output pins. These are pretty safe for inputs and outputs, and these can read and write signals that don't have to be 0 or 1. It could be something like 0, it could be something like 10, it could be something like 900. But if you're going for a value that's not in binary, then you probably want to use analog pins. Vin is your input voltage, and this should be connected to your 5-volt voltage regulator. GND means ground. We just want to connect these to ground, but we are going to decouple our TNT first. 3.3 volts, this is the output voltage pin, so if any of your components need 3.3 volts, then you can just attach it to this pin. TX is transmitter, this just means it sends out a signal. RX means receiver, this means it listens for a signal. And PWM is a digital pin, and this can read, write signals that are 0 or 1. Binary. Okay, and these are pretty good for inputs, outputs as well. But you want to check if your component either reads digital or analog. So I can go back to this picture and show you. For example, if I have a sensor that only reads digital, so it only returns a 0 or 1, I could use any of these PWM pins. So these like 0 through 12 right here, or 24, 25, anything with the PWM I can use. But if it's analog, I cannot use these PWM. I am forced to use these A0 through 17 pins. Alright, here are the steps to connect the TNC to power and ground. I'm just going to go ahead and show you myself. So, to access power, we click on this symbol right here, or you can hit P on your keyboard. And we're going to search out 5 volts, and we're going to connect it right here. Okay. And we have another 5 volts. This is 5 volt output. And we can connect that. I'm just going to copy this, move it here. And we have a bunch of 3.3 volts, and we can connect those as well. So we just search up 3.3. And we can make those connections. You just click on these circles and you connect the wires. So you can see here there are 1, 2, 3, 3.3 volt pins. We can see what those refer to on here. So we have one here, and I'm not sure whether, I think the other one's in this row somewhere, but that's okay. We can just go ahead and connect all of these to 3.3. And we need to decouple our TNC. What does that mean? All right, so we're going to hit add a symbol, type in capacitor. So I just type in C, and click this one, and we're going to place it. Let me organize this a little bit better. Move this to the left a little bit. we're going to need a ground to decouple this. So to decouple it, you just take your power and you connect it to a capacitor, and then from the capacitor you connect that to ground. And this capacitor should have a value of 0.1 microfarads. Cool. And we're going to do the same for the 3.3 volt side. Let's go ahead and I think just copy this entire thing right here. All right, good. And okay, I forgot to connect grounds. Let's do that real quick. We have a bunch of grounds here, and we want to connect all of these together. And we need ground. All right, good. I think that's all the power that we need. So we can move on. We're going to connect our sensors next. So to do this, we're going to use global labels, like I mentioned earlier. Depending on what sensor you have, you're probably going to have one for power, one for the signal, and a wire for the ground. So we can follow this picture right here, and we can make those connections. So I think we're just going to go down the list right here. So it starts at 5, and then it goes to ground, and then it goes to out. So I can show you what that looks like. We have our distance sensor here. So first was 5. Actually, this can also run at 3.3 volts. That is on the slideshow, so we're going to use 3.3 instead. So the first is the power, let's say 3.3. Next was ground. Oh, I did not stop. Gonna rotate that. Oops. Actually, no. I think that's okay. And the last one was the signal. So we're going to use a global label. It's this thing with the A right here. We're going to name this dist F for front. Rotate it. All right. And we make that connection right here. Okay, cool. So we're going to be doing this for everything. But first, we are going to decouple this sensor. So we're going to do the same thing with the 0.1 microfarad capacitor. Trying to figure out the best way to do this. I might rotate it like this. This is ugly. Let's move this ground a little bit over here. Make that connection and connect it to ground. Okay, cool. That is a little ugly, but it works. So instead of just making that entire circuit again, just delete all this. And just copy and paste. And this is not dist F, this is, say, back. This is, let's say, dist R. And let's say this is dist L. Okay, cool. So, yeah, you pretty much want to do the same thing for your line sensors and your start modules, but I would recommend paying attention to the pin layout because it's definitely not going to be the same as your distance sensors. Alright, so as you can see, I finished connecting my line sensors and my start module. That's all I did. pretty much what I did was look at the pin layout on JSumo, and I found out which pins were connected to what, connected to power, decoupled it, stuff like that. So yeah, you can look at that if you want. Next, sorry, wrong thing. Next up, we are going to connect these sensors and the start module to the TNC itself. So something I'd advise is to be aware of the positions of your sensors and pay attention to which side your pins are on, just so the wires don't overlap when you're making the PCB. And it's not a huge deal, but it will make your life a little bit easier when you are wiring. So yeah, and also make sure to keep track of which pins are connected to what, so that your CS teammate is able to code. Alright, so we're gonna take this picture, just copy. Let's put it here, and let's rotate it. So my PCB layout had the TNC like this. So at the top would be the front and the bottom would be the back. So we're gonna just use this convention to make our life easier. And my PCB had almost everything in the front and only one distance sensor in the back. So keeping this in mind, we're gonna start with their distance sensors. So if we want the distance sensor to be in the front, we can use any of these pins on top here. Since it's in the front, it's going to be in the center, so I think I'm going to go with A0 just because it's in the center. A0 is a PWM, so this can take digital, and that would be pin 14. So we go back to our schematic. We're going to add a global label. This needs to be the same name as our global label that we put on the front distance sensor. So I think that was dist F. And we're gonna put this on pin 14 and connect that. Nice. So basically you're just gonna do this for the rest of these. Again, I'm gonna do this off camera so that you guys are not bored out of your mind, but that is the general process. Alright, so I went ahead and reconnected some of these pins, and yeah, so I have the pins on the TNC, which are connected to the pins on the sensors and the start module. And here's just an example. This is one I did earlier, but it doesn't matter too much as long as the correct connections are made between the sensors and the TNC. I'd say the big thing to watch out for is make sure if it says analog on the sensor, if it's an analog signal, just make sure you connect it to an analog pin on the TNC. Same goes for digital. You definitely don't want to connect a digital pin to something that is not PWM. Alright, so next up we have motor drivers and voltage regulators. You're probably going to want to look at the data sheets for these, and you can follow the previous steps of adding symbols, power, and global labels to make the necessary connections. So this, for example, is my voltage regulator that I used. You're going to basically just recreate this entire schematic they have right here, but with it is pretty much by yourself. So I'm not gonna demonstrate how I did this, but you would just do the you just add symbols and power and global labels to do the same things that we did earlier to recreate this. Alright, so I went ahead and added the schematic for the voltage regulator and the motor drivers. And as you can see here, does not look exactly like the picture I showed you earlier, but all the connections are the same. I promise. You can check it out if you want. But it works, hopefully. And I have the motor drivers right here. Something to keep in mind is I have the outputs connected to a screw terminal, and these screw terminals are going to have wires that connect to the motors. And I went ahead and I attached these global labels to the TNC 4.1 as well. Alright, so we are almost done. So we're going to put X's on the unused TC pins now. And to do this, we're going to hit Q, or we're going to use this X thing right here. So click this. And for every unused TNC pin, we can go over it and mark them as unused. If you do not do this, you will end up with a bunch of errors on your electrical rules checker, which we are going to do next. Alright, that looks good. Alright, next step. We are going to use the electrical rules checker, and this is basically just a tool to help find errors that we may have made. So, to do this, we are going to click Inspect, and we have the electrical rules checker right here. And I actually already ran it, but let's run it again. So we're looking for errors and warnings. Some errors are going to be ignorable, such as this one, input power pin not driven by any output power pins. So you can click on it, it'll take you to wherever it sees the error. This error is ignorable, and these two are the same. This is ignorable, and this as well. This one right here, I did something weird to this part in particular, so I'm going to ignore this as well, but I assume some of y'all will probably not have that error. Let's look at some of the warnings. These could be ignorable, but sometimes they are fixable, so you could polish it up a little bit. As I said before, I did something weird to this part. So it says it's modified in the library of the part because I did something to it. Hopefully you guys don't have that problem, but I'm going to ignore this as well. Alright, so we are almost done. So the schematic should be good, but we're going to need some more parts. So you may have noticed that some of your components might need additional parts. For example, my voltage regulator required me to get some capacitors, inductors, a diode, stuff like that. So if you're getting capacitors and stuff, you want to make sure you get the surface mount if you can. These are decently easy to solder, and they're small. So for capacitors and inductors, make sure you get size 0805. There's a good trade-off between the small size and the solderability. So that would be this one right here. I'll be checking your parts list to make sure that you don't get anything massive like this 2220 or anything tiny like the 0402. Definitely pay attention to size and get the 0805 because it will make your life easier, and I will be less disappointed in you. So, congratulations on your new schematic. The next video is going to be about PCB design. So, if you made it to the end of the video, thank you for watching. Make sure to like and subscribe, and check out my other tutorials and my other videos as well. So, yeah. Thank you, and good luck on your schematic.